Hi, I'm Bruce Eaves.
I'm Eric Rostkowski.
Brett Barta.
Brandon Mann.
Macie Mateja.
We are all in Dr. Stacy Lyle's 352 class.
GPS, or Global Positioning System, is a network of about 32 satellites orbiting the Earth. The system was originally developed by the U.S. government for military purposes, but is now extended to civil purposes.
GPS receivers need to receive signals from at least 4 different satellites in order to accurately measure locations. The 4 circles that are shown in the picture accurately show the distances from each satellite to the receiver's position, and their overlapping position is the highlighted center, which is where all the circles overlap.
Multipath errors are caused when a satellite signal reaches the receiver from 2 or more paths, one directly from the satellite and the others reflected from nearby buildings or other surfaces. Signals from satellites low on the horizon will produce more error.
Receiver clock error is a vital concept in GPS surveying. Any difference in time between the satellite and the receiver can cause distance errors because the signals would be misaligned significantly, altering your data.
If the GPS receivers are close together, then theoretically any disruption from the atmosphere or multipathing from buildings or trees should be seen on all of the receivers. Normally, GPS receivers receive a WASP signal, which is a signal from a tower that uses its known location to measure the effects of the atmosphere on the GPS satellite's signals. The WASP towers send out signals which GPS receivers receive and change their locations based on the WASP signal. For this project, the GPS receivers will have WASP turned off.
The research question that we will be discussing is, will the accuracy of the difference in distances between multiple GPS units be subject to distance decay due to variations among the different satellite angles reflecting back onto the specific GPS locations on the troposphere? Testing this question will show the impact that distance and atmospheric conditions have on the accuracy of GPS receivers.
The difference in distance between 2 or more GPS units should stay constant over time. However, we think that with increased separation between the GPS receivers, that distance will not stay constant. Factors for this could include atmospheric, receiver clock, and multipath error. If multiple GPS units are stationary and taking their coordinates at the same time and place, then these effects should impact all of the GPS receivers in the same way. This should cause the variation between points to be the same from one GPS receiver to another.
In other words, we believe that as the distance between the GPS receivers increases, then the variation between each receiver during the same time interval will also increase.
First, we had to establish a control. Our control was a benchmark located on A&M's campus titled BM0028. From that, we took 25 GPS points at each successive benchmark at the same time of day with 10-second intervals between each captured point. We did this to ensure that each GPS unit capturing points were tracking the same satellites in the sky.
4 people from the group went to 3 different locations to test the hypothesis. The first location the 4 people tested waypoints at was on A&M's campus beside the academic building as the control center. The second spot was in various locations throughout the Bryan College Station area, also taking 25 waypoints. The final location was various locations dispersed throughout Texas. The next 2 videos demonstrate the actions of 2 of our group members when taking waypoints and the procedure that they followed for it.
Hi, I'm Bruce Eaves. I'm standing outside of Fannin Elementary School in Bryan, Texas. I am about to take some points for our project. So, if we can see, around here there's a lot of area for multipath notably these trees back here, as well as this pole, but a lot of the sky is open, so this should be good. And what I'm going to try to do is right at 4 o'clock, which is in right now actually. Okay, so what we're going to do is take points right above this benchmark at every 10 seconds. So just like that, wait 10 seconds, take another, just like that.
The 25 points collected from the benchmark S1307 in San Marcos, Texas, could have had an error as a result of the high percentage of humidity in the atmosphere on the day that the points were collected.
For the control set of points, 4 sets of 25 points were taken at the same time and at the same benchmark found in the academic building on the campus of Texas A&M University. For these sets of points, a definite eastward movement can be seen that is consistent throughout the 4 sets of points. There is some large error that occurs due to the fact that the benchmark is underneath a large tree. The tree and its leaves disrupt the GPS signals and cause the inaccurate readings to be measured. Here are scatter plots with lines with each between each consecutive waypoint and showing the location of each waypoint compared to the average point in the actual benchmark. The lines between each point show the change from one waypoint to the next.
For the second set of points, 4 sets of 25 points were taken at the same time at 4 different benchmarks around the Bryan College Station area. For these sets of points, there is a consistent northwesterly and southeasterly movement that can be seen on all of these data sets. 2 of the 4 benchmarks for this set of data were also under trees, leading to uneven multipathing on the waypoints.
For the state of Texas, 3 sets of 25 points were taken at the same time at 3 different locations in Texas. 1 taken in Victoria, another in Northwest Houston, and the last one in San Marcos. The trend and movement of the GPS locations varies between the different locations due to the unique atmospheric conditions relating to the angles of the receiver relative to the satellites being tracked and the varying ionospheric circumstances of each place.
We believe that as the distance between each benchmark increases, that the variation and change from one waypoint to the next would increase between the different GPS receivers. When testing this problem, the biggest challenge that occurred was due to multipathing error from trees, large buildings, and water. The waypoints that we collected confirmed our hypothesis and proved that the distance between the points increase. The variation between GPS receivers also increases. The effects of this problem need to be known in the professional field to prove that different post-processing stations are needed the larger the distance is between points.